This is 8.00 Algebra 2, and we are on the sum and product of the roots of a quadratic equation. For some reason, all my pens are black. Oh well. Okay, so to find the roots of each of the following, and there's just one of them, we're going to factor, so using guess and check. So let's take this and say what multiplies to negative 24 and adds to negative 2. Well, that's going to be negative 6 and positive 4. If I set each of these equal to 0, remember you have to show this step of actually setting each factor equal to 0. We get negative 4 and we get positive 6. So we're going to add those two together, 6 plus negative 4. 6 minus 4 is 2. And we're going to multiply them together. 6 times negative 4 gives us negative 24. So what we're going to come up with here is formulas to represent the sum and the product of the two roots using just this original equation. So think about this 2, the sum of 2 as 2 over 1. So where does a 2 come from? Well, if I had a different color, I would trace it. I can see a negative 2 right here. And a 1 I can see right in front of my x squared. So 2 over 1 is like taking the negated value for b, so negative b, over a, which is 1. Let's see if that works out with this one. So negative 24 over 1. That would give me negative 24 comes from over here. That's my c. And again, my a is 1. And these match up because a's are both the same. Both a's are 1s. So those are going to be your formulas to find the sum and the product of the root. So anytime you're asked for the sum, I remember this as samba. It's the sum of the roots, b, negative b over a, samba. And the producta of the roots is c over a. So samba producta. And that all comes from this in standard form, your quadratic. So ax squared plus bx plus c equals 0. That's where we're getting the a, the b, and the c from. Really straightforward question in number 2. Find the sum and the product of this given equation. So to find the sum, we're going to use the formula negative b over a, our samba. So we're going to take here, let's write these out real quick. A is 3, b is negative 7, and c is 12. So to find negative b over a, we're going to take our b, which is negative 7, negate that, so it's going to become positive, negative 7 over a, which is 3. So the sum of the roots will be 7/3. Now let's find the product. So for the product, we're going to use producta, which is our c over a. Our c is 12, our a is 3. We can reduce that to get 4. So what that means is if I were to have factored this or used quadratic formula and found the two roots of this equation, and then I added those two roots together, they would give me 7/3. If I took those two roots and I multiplied them together, they'd give me 4. So just like up here in this one, number 1, we found our two roots. If we add them together, that's the sum, which is the negative b over a. If I multiply them, that's the product. Now, you might be thinking, why do I need to be able to do this? Why do I care what the sum and the product of the roots are? Well, we care about them because they can help us to find the equation if we're given the roots. So if I know what the roots are, I might want to be able to write my equation. And there's a couple different ways you could do that. And some ways are easier than others. Sum and the product is kind of like a shortcut way. It kind of helps us out when some of these methods are a little bit longer to do. So for example, you could take this one. There's a few different ways you might think about it for number 3. If those are my two roots, I might say, oh, well, I could say then my factor would be x plus a half. If I set that equal to 0, I'd get negative 1/2. And then my other one would be x minus 3/4 equals 0. And then you could FOIL this out and that would give you your equation. Problem is, you're going to have to FOIL with all these fractions, so that can get complicated. And we're going to eventually be talking with radicals and imaginary numbers, and that gets very complicated as well. Another option for this one that I'd say is one of the easier ways is if you think about how you could get -1/2 from a factor without using the 1/2. So think, in order to solve this factor, I would have to divide by 2, which means opposite of division is multiplication. So I would need to be multiplying the x by 2. And I want it to be a -1/2. So I take the opposite sign there and make it +1. So if I were to set that equal to 0, I would subtract over my 1 and then divide by 2, getting my -1/2. And you could kind of think backwards for this one too. I'm dividing by 4, which means I'm going to be multiplying the x by 4 here. So if I were to set that equal to 0, I would add 3, divide by 4. So this one right here, so then you would have to FOIL and put in standard form. Same thing here. FOIL this out, and that gives your equation. I'm going to erase this part right here. So these are 2 different options of doing this. So option 1, option 2. And then what we're going to talk about is option 3. So honestly, if you were given just nice integers, like if I told you the roots were 3 and 5, I would set it up using this way. I would go, okay, so let's say my roots were x equals -3 and +5. So this is just another example. I would do x plus 3, x minus 5, because if I solve those, I'd get -3 and 5. And then I would set each of those, or I would FOIL those out and solve them. Or get the equation, sorry, I'm distracted by the phone ringing and I don't know where it is. So you're going to FOIL that out, and that would give you your quadratic. So that's the easiest way to do it if you're given nice integers. In this case, we're not really given nice integers. So let's talk about another way to do it. Another way to do it is to say, okay, well, let me take the sum of these 2 roots. So I'm going to add -1/2 and +3/4. At this point, you can just put that in your calculator if you want, or you could get common denominators, multiply the first fraction by 2 over 2. And I get 1/4. All right, so I know that the sum of the roots, is -b over a. So I'm going to set -b over a equal to 1/4, and I'm going to just pause there for a second, and I'm going to go over to the product. For my product, I'm going to take -1/2 and multiply it by 3/4. Multiply straight across the top, straight across the bottom, I get -3/8. So now for my product of my roots is c over a. I'm going to set that equal to -3 over 8. Now the problem is now that this one has a denominator of 4 and this one has a denominator of 8. They're both representing a. They're both in the denominator. So a is different, which means you need to make it the same. How do I make it the same? Well, it's easier for me to take this 4 and make it into an 8. So if I multiply the bottom by 2, I need to multiply the top by 2. So 1/4 is the same as 2 over 8. So now I can say -b is equal to 2. Let me write this again over here. So -b over a is now equal to 2/8. And c over a is -3/8. So a's are the same, so a must be 8. -b is equal to 2, so b is equal to -2. Just divide both sides by -1, and c equals -3. And now you just write the equation. So ax squared, so 8x squared minus 2x minus 3 equals 0. If I were to use p's and c's to factor this, and that would be a good check, I would get these 2 roots back. if I were to FOIL this out right here, I would get that same equation for my answer. Same thing for the option 1. If you were to FOIL that out, you'd end up getting that same answer. All right, let's try another one. So this one is a little bit trickier because, first of all, they only give us one root, and the root has an imaginary number in it. So if we say that we have 4 plus I is one root, there we go, a little color. You need to know that they always occur in conjugate pairs. So the other root is going to be the conjugate. So remember, for the conjugate, you only negate the middle between the two. So they occur in conjugate pairs. Okay, so we know that the two roots are 4 plus I, 4 minus I. As soon as there's an imaginary number or a radical, I no longer want you thinking to do one of these option 1 or 2 methods for these, because they just get really tricky. If you forget what to do and you try that, it will work, but many students, all the students I've seen that try this way, always make very silly mistakes, and it's just a lot longer because you'd have to do like x minus 4 minus I foiled with x minus 4 plus I. So you've got like 3 terms inside of that, and just gets a little bit messy. So whenever you see an I or a radical, really focus on using sum and product of the roots. So for the sum, we're going to take 4 plus I and add it to 4 minus I. The beauty of this way is that we combine our like terms. 4 and 4 is 8, and those i's actually cancel out. And I'm going to set 8 over 1, so make it into a fraction, equal to my sum bar, negative b over a. Then I'm going to do the product. So I'm going to take 4 plus I and find the product with its conjugate, 4 minus I. You want to FOIL these out. Now remember, you could always just go right to your calculator and type in 4 plus I in parentheses 4 minus I, and it will give you the answer. Do I want you to show work and how you get that? Yes, of course, but you have a check that will give you the answer, so use it. So nice. So these middle terms cancel out. We have 16 minus I squared. Remember, I squared is the same as negative 1. So that gives us 17. 17 over 1, we're going to set equal to c over a. So first thing you want to check now is, are the a's the same? And yes, they are. Both a's are 1. So I know a is going to be 1. Here, negative b is 8. So b must be negative 8. And c is 17, leaving me with the equation 1x squared minus 8x plus 17 equals 0. Number 5. We again have an I in our answer, or in our roots, so I want you to go straight to sum and product here. So let's find the sum of these two roots. So 6I plus negative 6I, oh, that gives me 0. So 0 over 1 is equal to negative b over a. And then find your product. So we're going to multiply 6I times negative 6I. That's going to give me negative 36I squared, because I times I is I squared, but I squared is negative 1. Negative 36 times negative 1 is positive 36. Put it over 1, set it equal to c over a, the producta. Check that your a's are the same, and yes, they are. They're both a 1. So we know a is 1. Oops. A is 1. Negative b is 0. So b is also just 0. And c is 36. So our final answer would be x squared plus 0x plus 36 equals 0. And usually we don't write those 0 terms. So x squared plus 36 equals 0 would be in simplest form. So it looks a little bit different there. But just follow the procedure and it'll get you to that spot. Okay, and then number 6, a little bit different. Given the quadratic x squared minus 6x plus k equals 0, if one of the roots is 4, find the other root. So first thing I look at is I'll say, okay, well, looking at this, I know a is 1, I know b is -6, and c is k. I don't know what it is. So what do I know? I know a and b. So if you know a and b, think what formula that we know uses both a and b. The sum, because the sum formula is -b over a. You only need an a and a b. So if I find the sum, so those aren't my roots, these are my a and my b values. So I'm substituting -6 in for b, so that's -6 over a, which is 1. Double negative becomes a positive. So 6 is the sum. That's the sum of the roots. If I know that my roots add to 6, then I know that one of the roots is 4. So 4 plus my other root has to give me 6. Well, solve for r. Subtract 4, and my other root has to be 2. Okay, same idea in number 7. So first, identify what do you know? Well, I know a is 1, b is k, and c is -15. So what do I know? I know a and c. So what formula do I have that has an a and a c in it? And that is your product. So we're going to use the producta. So for the product, we're going to take the product as c over a. So that's -15 over 1. So the product of the roots is -15. I know one of the roots is -3. So if one of the roots is -3, then how could I find the other one? I'm going to take -3 times my other root is going to give me -15. Divide that by -3, and that will give you your +5. So 5 would be your other root. And we know we have only 2 roots because the highest exponent is a 2. Okay, so now I know there's not another one on here, but I would like to add one with a radical so you see that before I set you off on your own. So let's, I'm just going to open up a new document here to write it out. So the question that I'd like you to do with me is find the quadratic equation whose roots are 1. Oh, and now we have different colored pens again. And again, these occur in conjugate pairs. So if this is one of our root, our other root will be 1 minus rad 3 over 2. So find the quadratic equation whose roots are these two. All right, so again, anytime it has a radical, I want you guys to use sum and product. So let's start with sum. So we're going to add 1 plus rad 3 over 2 plus the other root, 1 minus rad 3 over 2. So combine your like terms here. The rad 3 over 2s are going to cancel. 1 plus 1 is 2. The sum of the roots is -b over a, so we set that equal to 2 over 1. We put that on pause because we need to find the product of the roots and make sure that our a's are the same. So we're going to have 1 plus rad 3 over 2 times 1 minus rad 3 over 2. Again, this can be checked in your calculator, but I'm going to FOIL it out for now. So I have 1 times 1 is 1 minus rad 3 over 2 plus rad 3 over 2. And then my last terms, I have positive times negative is negative. Rad 3 times rad 3 is 3. And 2 times 2 is 4. So my middle terms cancel out. You can type this right in your calculator or just think of 1 as multiply top and the bottom by 4. So 4 over 4 minus 3 over 4 is just 1 over 4. So I'm going to set my product C over A equal to 1 over 4. Okay, so check your A's. My A's are not the same. So since my A's are not the same, I need to get them to be the same. It's easier to get my smaller one to become bigger. So I want the 1 to become a 4, since this one's a 4 and this one's a 1. So I'm going to multiply the top and the bottom by 4, giving me 8 over 4. So now negative B over A equals 8 over 4. I've got A equal to 4 in both of them now. Negative B is 8, so B must be negative 8. And C is 1. Final equation, 4x squared minus 8x plus 1 equals 0. Again, you're getting that equation by doing ax squared plus bx plus c equals 0, your standard form of a quadratic. Okay, so hopefully that gets you set up to do the homework on your own. And if you do have any questions, let me know. Hope you're staying healthy, staying strong, loving math, and pie out.